английском.
So this right here is a Trilaurin, and it has 39 or 36 carbons. So this molecule is a fatty acid, which means it has a glycerol on one end, on this end, and a bunch of carbons on the other end. So you can see a bunch of carbons. But the fatty acid technically contains oxygen, and some of the fatty acids are actually soluble and are liquids. So you can see right here, this Trilaurin is actually insoluble. The reason why is that there's this oxygen right after the second carbon and an oxygen on the fourth. So there are so few carbons, that are surrounded by the oxygens, only these four. The molecule is just insoluble, so the part that doesn't like water is significantly larger than the part that does. But this doesn't always happen. For example, in fatty acids with fewer than 3 carbons, they are completely soluble. But after 3 carbons, solubility decreases significantly because you've got carbon away from the oxygen, so right here. And then after 6 carbons, you can just consider the fatty acid to be insoluble. And also the fatty acid becomes solid instead of liquid. The reason why, you have this double bond right here. So in these very short fatty acids, they're kind of an exception, but they can be liquids. But in the other one, and it's fatty acids, it's just they're close enough to a double bond. But if they're far enough from a double bond, they won't be bent. So the reason why these fatty acids aren't liquid is because they just aren't bent. For your molecule to be bent, you need to have a double bond somewhere, and not like a trans fat or something like that. You need to actually have a bend. The more bends, the more probable it's a liquid, but it doesn't impact its likeness to be in water. It will still be the same. So, for example, in terms of stearic acid, a fatty acid which has 20 carbons, you have leidic acid, which is a strange one because it has a double bond, but just isn't bent. It needs to be not 2 straight lines, but a bend like this, and then the molecule is going to continue after that bend. It can't be like a plain double bond to an oxygen and then the carbon chain continues down there. It just must continue after the double bond. So if you get olive oil, for example, you actually have a double bond in the middle of the structure. So there is actually a bend here. There's actually a bend. And so the molecule's shape is different. Even though that only happens for one chain, the thing is that this really affects the whole molecule structure. This affects the whole thing because it just becomes unsaturated, and if there are enough double bonds, if there are 2 or 3 of them, your molecule can already become a liquid, even though it doesn't really like water or anything like that. Thank you. Bye.